Hello, welcome back. How do we solve for k in this exponential equation? Solution. We have k minus 3 to the power of 4 equal to 3 to the power of 4. This left hand side could be written as k minus 3 times 2 equal to 3 to the power of 4. We can also rewrite it as 3 to the power of 2 times 2. Now, let us transfer this right hand side to the left side. So we are going to have k minus 3 to the power of 2 times 2 minus 3 to the power of 2 times 2 equal to 0. Recall that whenever we have a to the power of 2 minus b to the power of 2 is the same thing as a minus b times a plus b. Take note of this property. By comparing this left hand side with this left hand side, you will notice that our a is all of this, k minus 3 to the power of 2, and our b is 3 to the power of 2. By substituting the value of a and b into this right hand side, we are going to have k minus 3 to the power of 2 minus, what is b? B is 3 to the power of 2 times, what is a? A is k minus 3 to the power of 2, k minus 3 to the power of 2 plus, what is b? B is 3 to the power of 2 equal to 0. Let's proceed further. If you expand this guy very well, k minus 3 to the power of 2, you are going to get k to the power of 2 minus 6k plus 9 minus, what is 3 to the power of 2? That is simply 9 times k minus 3. If you expand it very well, you will get what we also have here. That will be k to the power of 2 minus 6k plus 9 plus 3 to the power of 2, that is 9, equal to 0. What do you notice here? You will notice that 9 minus 9 is 0, so we are left with k to the power of 2 minus 6k times k to the power of 2 minus 6k plus 9 plus 9, that is 18, equal to 0. Let's continue. This implies that k to the power of 2 minus 6k is equal to 0, or k to the power of 2 minus 6k plus 18 is equal to 0. Let us focus our attention on this guy first. K to the power of 2 minus 6k equal to 0. It is possible to pull out k, so we are going to have k into k minus 6 equal to 0, which in turn gives k equal to 0 or k minus 6 equal to 0. K equals to 0 is the first solution. From this guy, k is equals to 6, which is the second solution. Now, back to this guy, we can also solve it. K to the power of 2 minus 6k plus 18 equal to 0. This quadratic equation, we can solve it using quadratic formula. That means our a is equals to 1, and our b is equals to negative 6, and our c is equals to 18. What does the quadratic formula say? It says k equal to minus b plus or minus square root of b to the power of 2 minus 4 times a times c all over 2a. K equal to minus, what is b? B is negative 6. We have negative 6 plus or minus square root of, what is b? B is negative 6. That will be negative 6 to the power of 2 minus 4 times, what is a? A is 1. So we have 1 times, what is c? C is 18 all over 2 times 1. Let's proceed further. K equal to minus times minus 6, that is 6, plus or minus square root of negative 6 all to the power of 2, that is simply 36, minus 4 times 1 times 18, that is 72, all over 2 times 1, that is 2. K equal to 6 plus or minus square root of 36 minus 72, that is negative 36, all over 2. Let's proceed further. K equal to 6 plus or minus square root of negative 36. We can write it as square root of negative 1 times square root of 36 all over 2. K equal to 6 plus or minus square root of negative 1 is I from the complex number, and square root of 36, that is simply 6 all over 2. It is possible to pull out 2 from this numerator, so we are going to have K equal to 2 into 3 plus or minus I times 3 all over 2. Clearly, 2 cancels 2, so we are left with K equal to 3 plus or minus I times 3. This implies that K is equal to 3 plus I times 3, or K equal to 3 minus I times 3. Therefore, K1 is equal to 0. That's the first solution that we obtain. K2 is equal to 6, the second solution. And K3 is equal to 3 plus I times 3. And last but not the least, K4 is equal to this guy, 3 minus I times 3. These first two solutions are the real solution, and these are the complex solution. That's it for this video. Thanks for watching.